Hey everyone, welcome to the fifth episode of the Hypernode developer preview. Today we're going to take a look under the hood. This episode is about the GONE layer, which makes sure your server, your Hypernode server, doesn't get flooded with requests that aren't really doing anything. So yeah, this way you get the most out of your Hypernode when you have quite some traffic. So yeah, Rick has a lot to talk about. So please take it away.
Yeah. So we have this very old changelog from 2017 where we talk about the Hypernode GONE layer. We don't really have a good name for it. We call it smart request handling in some different places. This is a component that has been part of Hypernode for a very long time. But it's really significant. I don't think many people know about it or how it works. So I just wanted to dive into that today and show you guys how this GONE layer works and what it does and why does it do it like that. We often get questions from people who do what do you call it, performance testing on Hypernode, where they just call web shops and see how they perform and things like that. But we have a lot of mechanisms in place to make it so that one single user cannot abuse your site, and there's rate limiting and all these things to make it more efficient. So we really thought about how we should make a Magento shop perform more efficient, and one of those things is this GONE layer. So I have this Hypernode prepared for you today to show. It's just a Magento 2 sample shop, nothing special. It's on a Hypernode, but I'm going to display how this mechanism works, this GONE layer. So basically, if you go to any website and you refresh and you refresh and you refresh, it's going to start firing requests at the backend server to render these pages. So my browser talks to Nginx, then talks to PHP FPM, that starts calculating the page, and it sends back the data. But if I start refreshing, then those previous requests are still running. So, in theory, if there's no rate limiting on anything like this, I can just, keep the refresh button entered all the time, and then the site will fall over. So we have a mechanism in place to prevent this. The one main thing, of course, is IP-based rate limiting, user agent-based rate limiting, stuff like this. But I've disabled those on this test server to show you something else. So how I've disabled that is simply like this. I just said, okay, we have this rate limit inject configuration where nothing is rate limited anymore. So now I can, from my one IP, start firing requests to the server, and I just can fill up all these slots. So if I run live FPM, I can inspect the state of the PHP FPM workers. And then if I have a different terminal where I do curls to this site, for example, like this, then you will see those requests in PHP FPM. So my site isn't very slow, so this is not very interesting to look at. So we can introduce a sleep in the site to make it a bit more clear of what's going on. So in my Magento shop, I'm just going to add a simple sleep over here. And now if I do the same thing again, this curl, you can see these requests running. So my request is running, it's running. And after 10 seconds, it's going to return the result to me. So you can see it after 10 seconds, it's gone. And I can do more requests like this. So if I background this and I do another request, then I have 2 requests running. Now I have 3 requests running, stuff like this. But what if I terminate my request? Then we can actually detect if it's gone. So we call this gone, but actually what this means is that the TCP state of the Nginx socket, it has a state, it's called TCP close. And then we can actually see that the client has disconnected. And that information is very valuable if you have a server that is almost overloaded. So we can start doing this in a loop and see some interesting things. One, two, curl, done. Oh. Okay, so I'm doing these requests now. I'm going to say after 1 second, time out 1 second, just kill the request and then proceed with the next iteration in the loop. Now we can see these requests stacking up here. And this Hypernode is actually a bit more special because I disabled the second phase of this killing mechanism, which is over here. I disabled a cron that users cannot disable themselves. I'm just going to show this for display purposes. But here you can see I'm actually filling up this job board. And what's actually really interesting is my busy requests are still making it onto the job board, even though I'm in this loop just doing these calls all the time. And how does that work? Well, we have a module. It's called PHP Hype Mode. It's on GitHub. And it's actually a module inside PHP, inside the PHP FVM daemon, that can detect the state of the socket to see if I'm disconnected. So if I'm going to look for this is where the magic happens. So basically what it does, there is this queue of requests coming in. It cannot go to PHP FVM because the workers are full, and then this queue starts building up. And as soon as one of the PHP FVM workers is freed up, then one from the queue can enter the PHP FVM queue. But if at that point the visitor has already clicked away, they closed their browser, they refreshed, then we don't want to give that request to the PHP FVM queue. We just drop it. Because if at that point the client's already gone, then we don't really care about this anymore. So that's a really efficient way for us to, with a small server, still handle a lot of extra traffic if the server is about to go to that point where it's overloaded. So that is the first phase of this mechanism, but there is a second phase, which is the GONE Slayer. And I can show you how that works. So normally we have a cron that runs every minute that performs this FPM monitor process. FPM monitor, where is it? Hypernode. And I can just run this in the foreground now to display what it would be doing. So here you can see that it actually checks the PHP FPM job board, and it sees the state of all the workers. And if there are many GONE requests on the job board, then it will start killing these GONE requests very quickly. But there is a heuristic here as well, so it doesn't kill post requests as easily because post requests are more dangerous to kill than, for example, GET requests. So it's a bit clever in that way. It also starts killing really fast as soon as it detects all of these GONEs are currently present. So this is running all the time on Hypernode, which means that if you have a website where you're just going to be refreshing the page all the time, eventually your request is still going to come through. It's now slow because we have to sleep in there, of course. And you can see this all happening in real time if you run live FPM. So now with this cron that usually runs all the time, you can actually see that the job board gets cleaned up of less important requests. So these cron requests are killed because the user has already clicked away. Okay.
Yeah, so one thing that I would like to add is that currently we are showcasing like just refreshing the page and stuff. This can also happen a lot. Like, for example, when you have a queue system or something for a big sale, or people are waiting for your site to become available, that can be very bad for your server because it starts flooding your Hypernode. So that we prevent that situation from happening with this mechanism. But one other thing that's also really nice to have, or what it also solves, is that Magento can do quite some AJAX requests, like in the background from your front end. So things like checking if there are messages, or checking what items are in your cart, or adding stuff to cart, or yeah, you can have many requests happening that are triggered from the front end in the background. So even when you click away from that page and you have like pending requests that are running, those will also get killed as well. So that's also really nice to have in place. So yeah, I just wanted to add that.
Yeah, and so this is a mechanism that only triggers if you're at the point where your PHP FPM job board is full. So we do have a dynamic PHP FPM amount of workers. It's based on the amount of CPU cores you have in your plan. So if you have a very big Hypernode, this is not so likely to be triggered. But if you're on a plan where you're barely hanging on to the amount of traffic you're processing, this can really help you handle that extra boost. It's also a way to gracefully degrade this performance cap you could have on a server. Yeah, and I just think this is a really clever way to deal with the situation where you're actually out of PHP FPM workers. So at some hosting companies, they just make any amount of PHP FPM workers based on the amount of visitors you're getting. We actually pin this to a maximum because this is based on a lot of benchmarking that we did in the past, where this was the optimal for the maximum throughput on the average application that we see on our platform. So it's actually better to not just make any amount of workers, because then you're going to bog down the whole server and make it slower for everyone. So sometimes it's better to just make it all go to the same queue, make it all go to the same amount of workers, and then you just keep an eye on the quality of the requests that are going through. So if it's callers, they are way more likely to be hindered by this mechanism than actual visitors clicking around on your site.
Yeah, so that's also the reason that the list wasn't growing and growing, right? Like at some point, it was just like 10 gone requests that were being processed, and one that was actually busy. So
yeah, so this is actually a pretty small plan. So I think this only has like 10 PHP VM workers, but if you would look inside Nginx, there would actually be a queue there building up of all my requests. And then those requests would be passed to PHP FM. And the PHP FM master would then perform this code where it checks the TCP state. And then it doesn't give that request to the PHP FM daemon. So it doesn't even make it into PHP FM. And then inside PHP FM, there we again check all the current running requests to see if there are too many of these gone requests stacking up. And then we start killing them. But we don't kill it if it's not necessary. So if your server is chugging along fine, you have plenty of workers available, nobody's waiting for anything, then nothing is killed. Okay, so this was a short demonstration about the Gone Slayer. Hopefully this was informative for you guys using Hypernode, and it may also explain some of the behavior you guys are seeing. Definitely keep this in mind in your benchmarks. If you really want to perform a true benchmark compared to a hosting platform where there aren't mechanisms like this, then it might be good to disable some of these things. Also, the IP-based rate limiter and user agent-based rate limiter, stuff like this. Okay, then thank you for listening to this episode of the Hypernode Developer Preview, and we'll see you guys next time.
Yeah, thanks for watching, and see you next time.
Bye.